Good morning. So today we're going to solve question 50 from GATE CSE 2021 set 2. This is from set 2. The question states that let S be a set containing 10 elements. Okay. The number of tuples of the form A comma B such that A and B are subsets of S and A is a subset of B. This is the question statement, the problem statement. This question can be solved with two distinct methods that I'm going to teach you. The first method is by means of the binomial theorem. This is something that was taught in 11th and 12th class also and in engineering mathematics also. So I'm going to be using it to solve it. And the second possibility of solving it is by means of considering all possibilities in which the elements can be placed, right? I'm going to give you both of the solutions so that you can have a better understanding of how you're getting to an answer in this particular scenario. Okay, so let's just see what all information has been given to us in the question. It is telling us that S is a set, A and B are also sets. Okay, so S is a set containing 10 elements. So that is a piece of information which would be that S is a set and the cardinality, the number of elements of S, any set that you've put inside of this is going to give the this n and this brackets is going to give you the number of elements inside of that set. This is a notation, right? So the cardinality of S is given to be equal to 10. Okay, what else is being given to us? The number of tuples of the form A comma B. Okay, so A and B are sets. I'm assuming that A and B are sets? Because this expression is for subset, right? So if we are writing this, A is a subset of B. For this expression to be present, both of these have to be sets, right? And we have given that A and B are subsets of S. So A and B are subsets. They are not giving us proper subset. They are giving us only subset. So we have to put a line below this also, because when some A is a subset of B, then A cannot be equal to, A is a proper subset of B, then A cannot be equal to B. But when A is only a subset of B, right, in that situation there is a line over here because A could also be equal to B. That is also a possibility that has to be considered, right? Right now, because they have not mentioned proper subset, so I am putting this line over here. So A comma B are subsets of S, and at the same point, they are telling us that this statement that A is a subset of B, right? This part they have told us. So because of this, A and B are subsets of S, right? And A is subset of B. So what we have is this thing that your A is a subset of B and B is a subset of S. So this information and this information is all the information that they have told us, right? There is nothing else that we can introduce inside of this, and from this we have to find this numerical answer. Okay, so now let's look at the binomial theorem method that I'm going to be using to find the answer. The first to do that, we have to consider a concrete assumption for imagination, because when we know that the set S has 10 elements, we cannot able to visualize what exactly are we given, right? To do that, we have to take concrete example, and over here, if you have to consider 10 elements and no information about the elements is introduced, just consider numbers 1, 2, 3, 4, 5 until 10. These numbers are going to be your elements of S, and with these numbers inside of S, the size of S is given to be 10. Very good. Now, what all possible values of A and B can be made, right? There is this assumption of this part, but let's not consider it and consider comprehensively what all possible values of A and B can take, with A and B being subsets of S, this part being present. Okay. So if we were to do that, what is the set which holds all possible subsets of a particular set? That set is called power set, right? And that power set is represented by this, that is phi empty set, 1 being directly taken from here, 2 being directly taken from here, then 2 of them being grouped together, likewise then 3 are going to be grouped together, and likewise all possible sets have been written. The numerical expression that gives the size of a power set is basically 2 raised to the power of n cardinality of S, and cardinality of S has been given as 10. So the answer over here, the size of the power set over here is going to be 2 raised to the power of 10. Okay. Now, the restriction that has been imposed by the question is that A has to be a subset of B, right? So B as being a subset of S, that part we have already considered over here. But so B can take all possible values. The condition for A is even further restricted, but B can take all values of the power set of S, that is these. There is no restriction on B. The restriction of A is now we have to consider. Let's see one more thing. I know the problem over here that students face is that the number of possibilities are enormous, right? And that thing scares students, not because it is impossible, but because it is going to take a lot of time, right? But as humans, we have the capacity to perceive patterns, right? So let's try to perceive the pattern of this so that we do not have to take all possible cases and we get to an answer in spite of not looking through all possible cases, right? So let's start with the smallest possible example and then see how the pattern actually manifests itself, right? So when B is phi, B is empty set, right? We can take all of these values from phi till 1 till 2 till all of those single elements being taken, then 2 elements being grouped together and 3 elements being grouped together likewise, right? So when B is phi, A can take only value of phi because A is subset of B. So total cases values of B can be 1 only with this kind of only 0 elements being present, right? Total cases can be 1 and A can take a value of a single value phi. So a single ordered pair can be made. So the size number of ordered pairs made is 1, and because the pattern for B is also 1, so multiply them together we get 1. Okay, now let's look at this. If B were to be equal to a single element 1, in this situation it could have been 1, it could have been 2, it could have been 3. So total number of cases would have been 10 that B could have taken for a single element being considered, right? Now A can be phi or it could be 1, true. So put these into the ordered pair while B part is fixed by this. We have what? We have phi and we have 1 and we have 1 and 5. Why have I written it like this? It has to be 1 comma 1, right? Like this. After this, what do we get? The total number of ordered pairs are 2 and the total number of cases that can be taken for B are 10. So multiply them together, you have 10 times 2, that is 20. Okay. Now look for one more time because 3 times makes a pattern, right? So we're going to consider one more time so that we don't make mistakes, right? 1 comma 2, total number of elements, total number of cases for this is going to be, we have given 10 elements and from those 10 elements we have to consider only 2 of them, right? So this time a expression of mathematics known as combinations can be used. If you must be aware of combinations. If you're not, then search on Google and type just combinations in mathematics. You're going to get a very good idea of what exactly these are. These are exactly what I am using it for. That is, from 10 elements we are considering 2 elements and total number of ways in which we can take 2 elements from 10. It has a formula also, right? So everything is present. So if you don't know this, search on Google. If you already know this, have forgotten, search on Google. Google is for everything, just revision and for studies. Do that, and from that we can, this is also an expression. It's also written like this in some books, so I've written it over here so that you have reference, right? So the values of A would be phi. It could be 1, it could be 2, it could be this whole thing, right? Because A is a subset of B, right? So whenever B is present, whatever B is present, for that A takes all possible values that the power set of B is going to hold, right? This is something that we will observe when we do three iterations of this, right? When we did 3 iterations, this pattern basically becomes very easily available, right? So from this, once we have a B, once we have fixed a B, we observe that the value of A is going to be an element inside of power set of B, right? This is something that comes from A being a subset of B already, but from sometimes we are not able to directly apply it. But here, by taking the cases, we understood that yes, A could be any element from that is inside of power set of B, and for every element that is inside of power set of B, that many number of ordered pairs ordered pairs has two portions, right? Left portion and right portion. The left portion can take possibilities that are equal to the cardinality of power set of B, because power set of B has 2 elements, so power set is going to have 2 raised to the power of 2, that is going to be 4, right? So 4 possible cases have been present because of that. And the right side of the ordered pair is going to have how many cases? This tends to So this is going to be 10C2, this is going to be 4. So the total number of possibilities that can be taken over here is going to be equal to what? It is going to be equal to 4, that is 2 raised to the power of 2 cross your 10C2, right? Likewise, you don't even need to consider all other cases. This is enough to get you accustomed to the pattern that you're going to actually get, and the answer is going to be equal to 10C0. This is the first part when we took B as 5. The cases are 1 and 1, the answer is 1. That is basically equal to your this 10C0 2 raised to the power of 0. 10C0 is going to be giving you 1. This thing is going to become 1. This thing is going to become 1, and the answer is going to be 1, right? Fine. This thing is going to give you 10. This is going to give you 2. This is going to give you total of 20. Likewise, this thing is going to give you something of value, I know, and this thing is going to give you 4. Likewise, and so on and so forth, and you get till this whole expression, right? Now, when you get to this kind of expression, now this thing is if you have solved binomial theorem questions, this thing is exactly the format that is present and can be used, right? And this is the expression for binomial theorem, right? A plus b raised to the power of n, we expand it like this. Put n is equals to 10, a is equals to 1, and b equal to 2. You're going to get this exact expression. And because of you get this exact expression, right, you have 1 plus 2 raised to the power of 10. So what do you get? 3 raised to the power of 10, right? Very easy. So you got the answer, 3 raised to the power of 10. And because in the gate examination, you're given the calculator with you, you can find the answer exactly. Right over here, I'm not using calculator. I'm basically using Python interpreter because that also gives you answer in a more expressive manner. And my aim here is not to just solve question, but to express it to you the exact answer, right? Two star expression inside of Python represent raised to the power. It basically, this part basically means 3 raised to the power of 10. I'm calculating like over here, and that is going to give us 59049. Okay, that is the answer that we're going to get for this question. And if in the examination you put the answer of 59049, you're going to get your marks in this question. It's going to be a 2 marks question, and it's a question that you can solve. It's not very difficult, right? Because I promise that I'm going to give you 2 solutions for this. I'm going to do exactly that. The second possibility is going to be considering the placement possibilities of the elements, right? So let's do that. So over here is that, right, I'm going to solve it by means of trying to place the elements, right? So if consider x as belonging to S, right? So x can take the value of 1, it can take the value of 2, right? It can take the value of 3, and it can take the value so on till 10. All of these are possible. Very good. Now we have 2 sets that we are considering. We know that x is belonging to S, and A and B are subsets of S. We know that. Okay, this part we know. Now there are 4 possibilities. X could not belong to B, and x could not belong to A, and x could not belong to B, right? So this x over here is not belonging to either A or B, and it can still be part of S because B is a subset of S. There are other portions of S that are still present, so x can still take values that are outside of B. Very good. So this possibility of x not belonging to A or B, both of them, is true, is valid, and meets the specification, the criteria given to us by the question. Likewise, when x is belonging to A and x is not belonging to B, let's see, x belongs to A and x does not belongs to B. But we know that A is a subset of B, right? A is a subset of B. So this thing is absurd, because there could not be an element in, if A is part of B, this is B, right? A is part of B, then in the situation there could not be an element inside of A that is not part of B. So this part is not possible. Likewise, when you consider this thing, when x is not belonging to A but it belongs to B, so this can be this part, very easily possible. So this is possible. Likewise, when x is not belonging to A and x is not belonging to B, is that possible? Oh no, I've written it wrong over here. X is belonging to A and x is belonging to B. Let me correct this because this is a mistake. Let me correct this. Very good. So x is belonging to A and x is belonging to B. So if x is this thing, so it belongs to A also and it belongs to B also. This is also a possibility. So for every x, these 3 possibilities are possible while this thing is not, right? So what does that mean? It means, and it is kind of comprehensive because every single element has been considered, so it is very comprehensive. It is not that any single possible case has been ignored, right? So a single x can take 3 possible values, right? A single x can take 3 possible values. X can be 3 possible values, right? for x being 1, there are 3 possible values. For x being 2, there are again 3 possible values, which are completely independent. Likewise, for x being 3, there are 3 possible values. And likewise, there are total number of 10 elements, right? These 3 possibilities are present now. So 10 elements are present. So 3 raised to the power of 10 is going to be your answer. I know this is kind of directly not visible, I know, but when you consider it, it is correct because it is comprehensive by means of exhaustion. Because every exhaustive basically means that including everything possible, right? Everything possible has been considered, hence the answer is correct. I know it seems a bit of counterintuitive, but think about it in this manner, that every single ordered pair that would be created, right, in that ordered pair, the x can take different values, right? And those values that x can take inside of a and b that are going to be formed, they are going to follow these 4 possibilities only, and we are excluding by means of observation this kind of possibility whenever it emerges, right? So what are we left with? We are left with this possibility, and this possibility, and those possibilities for every single x independently taken would is going to be multiplied and giving you the same quantity. You're getting the same quantity. This is a very good validation from your part that you're getting the same answer. It's kind of a very beautiful, if you understand. And mathematics in general is beautiful, and this is exactly an example of that. And with that, I've solved this question. I hope that you learned something or some part of your concepts have been revised, and I will see you in the next video. Thank you.